seen concepts of laminar flow. We have calculated what is shear stress, velocity, average velocity, and flow through the pipe, flow rate through the pipe. So let us solve few problems on laminar flow and its application in real fluid flow. So let us consider a problem which is given over here. A pipe of diameter 20 centimeter, length is 10 raised to 4, has a lead slope of 1 in 200 meters. So, and an oil of specific gravity 0.9 and viscosity 1 point is pumped up at the rate of 20 liters per second. So the following things are given to you. We have diameter 20 centimeter, L is 10 raised to 4, theta is 1 in 200, and oil of specific gravity 0.9. So this is specific gravity. Viscosity is given to you as mu, and pump at the rate of that is 20 liters per second. So this all things are given to you. So what we have to calculate, find the head loss due to friction, that is frictional head loss, and calculate the power required to pump the oil. So we have to calculate the power. So let us write down all the things which we know. So first thing is diameter and length. So diameter is equals to data. Diameter is equals to 0.2 meters, that is 20 centimeter. Length is equals to 10 raised to 4 meters. Next, theta is equals to 1 upon 200. Then specific gravity is given to you as 0.9. Hence, density of that oil will be equals to 900 kg per meter cube of that liquid or oil is given to you as 900. Next, viscosity, that is mu is equals to 1.5 poise. So this will be equals to 0.15 Pascal second. So we have converted everything in SI unit. And lastly, flow rate is given to you, that is 20 liters per second. So 20 into 10 to power minus 3 meter cube per second. Now to find over here, we have to find value of HF, that is head loss due to friction, and that is the first part. Next part which we have to find out, that is power loss during this entire part. Now first thing, we need to calculate head loss. The formula for head loss is given as 32 mu U bar L upon rho G d square, that is the head loss due to friction, and the power is given as rho G H L into Q. So we need to calculate what is the head loss, and this is what is frictional loss. Now let us calculate few terms. So now for calculating this entire part, you need to know value of viscosity, which we have. We have value of viscosity, we have length, we have rho, we have G, we have D. First thing which we have to calculate is U bar. For that, what we have given is Q as well as the diameter. So we'll calculate U bar, that is the average velocity of the fluid. So how will we calculate U bar? U bar will be equals to Q upon area of cross section. So that will be equals to, this will give us 60 into 10 to power minus 3 is Q, and pi by 4 diameter is 0.2 square. So on evaluating this, U comes out to be 0.63 meters per second. So we have calculated what, which is value of U. Now whether this flow is a laminar flow or turbulent flow, we have no idea about that. For that, we should first calculate Reynolds number. Reynolds number is rho U bar D upon mu. The value of rho is given to you as 900, U bar is 0.36, D is 0.2, and mu is given as 0.15. So on calculating all this, you come to a value of 763.2, that is value of Reynolds number. It is less than 2000, hence the flow is a laminar. Hence the flow is laminar. Now over here, let us draw the diagram of that entire pipe. So the entire pipe is very long in length at a slope of 1 in 200. So it is somewhat like this, and this is section 1 1, and over here we have section 2 2. With the horizontal, it is inclined at some angle. That angle is theta. Now this length over here is 10 raised to 4, and the opposite side over here, the ratio is given to you. If it is 1 meter, then the horizontal distance covered is equals to 200 meters. So we have to calculate, if you consider this as the datum line, so this as the datum line, so this is z1 is equals to 0. We have to calculate how much is it at a distance of z1 and z2. What is this difference between z1 and z2? So to calculate z2, what we'll do is we'll first calculate value of theta. So theta will be equals to tan inverse of 1 in 200. Now over here, the part is, we know that tan theta is equals to sine theta upon cos theta. If theta tends to 0, cos theta tends to 1. We know this value. Then sine theta is almost equals to tan theta, and the value of z also is linked with that part, but then too will calculate the value of theta, that is tan inverse of 1 in 200, which comes out to be 0.248. Now over here, the value of z2 will be equals to, value of z2, that is the difference, will be equals to 10 raised to 4 sine of 0.24. The value of this comes out to be 50 meters. So now we have calculated the value of Z2. Now let us calculate what is the head loss in this entire part. So now let us apply Bernoulli's equation between section 1 1 and section 2 2. So what we'll get over here, that is P1 upon rho G plus V1 square by 2G plus Z1 is equals to P2 upon rho G plus V2 square by 2G plus Z2 plus the heat plus the head loss. Since the diameters are constant, V1 and V2 will be same. V1 is equals to V2. The value of Z2 minus Z1 is equals to 50 meters, which we have already calculated. Now, the pressure loss between these two parts, which we have seen, that is P1 minus P2 by rho G, that is pressure energy loss, that is equals to 32 mu U bar L upon rho G into D square. So this is what is pressure energy loss. Now from this part you will get the total loss over here. So let us evaluate this part. So the value of P1 and P2 will club together. So this is P1 minus P2 upon rho G plus Z1 minus Z2 is equals to the head loss. So the pressure loss is equals to 32 mu U bar L upon rho D square. So let us evaluate in this equation. So P1, that is P1 minus P2 upon rho G is equals to 32 mu U bar L upon rho G into D square. Let us substitute those individual values. Now this will be equals to, this is 32 value of viscosity. We will substitute from the previous part, which we know, value of viscosity. Viscosity is 0.15, so we'll substitute this as 0.15. u, we have calculated u bar, this is 0.636. The length is over here, that is 10 raised to 4. We'll substitute the value as 10 raised to 4 upon rho, which is 900, into 9.81 acceleration due to gravity, into 0.2 square, that is diameter square. Now you have plugged in all the values. So after calculating this, it comes out to be equals to P1 minus P2 by rho g is equals to 8.81 meters. So we have calculated what is pressure energy loss. So we have calculated what is value of P1 minus P2. So P1 minus P2 will be equals to 8.81 into 9.81 into rho is 900. So the power can be also calculated as P1 minus P2 into capital Q. So this is 8.81 into 9.81 into 900 into value of Q, which is 60 to the 10 to power minus 3. So the power is equals to, comes out to be 98.94 kilowatts. So we have calculated what is the power. So I hope you have understood how we have substituted the formula for power as well as head loss in this entire equation. Thank you.